sampling. In the case of gases there is absolutely no trouble in mixing. The only difficulty is in drawing off a fair sample where, as in flues, the body of the gas is in motion and varies a little in composition from time to time. In this case care must be taken to draw off uniformly a sufficient volume of the gas during a prolonged period. Any portion of this larger volume may then be taken for the analytical operation. In the case of liquids, which mix more or less easily, and this class includes metals, etc., in the state of fusion, more or less severe agitation, followed by the immediate withdrawal of a portion, will yield a fairly representative sample. In the case of solids, the whole mass must be crushed, and, if not already of fairly uniform quality, mixed before sampling can take place. Most of the material which a sampler is called upon to deal with is, however, in a more or less divided state and fairly uniform. In practice it is assumed that 5% of the whole, note 1/20th, end note, if taken in portions of equal weight and at frequent and regular intervals, will represent the mass from which it was taken. Taking a heap of ore, A, and selecting 1 out of every 20 spade, bag, barrow, or wagonfuls, according to the quantity of stuff in the heap, there is obtained a second heap, B, containing 1/20th of the stuff of the heap A. If we crush the stuff in B until this heap contains approximately the same number of stones as A did, which means crushing every stone in B into about 20 pieces, B will become the counterpart of A. Selecting in the same manner 5% of B, there is got a third heap, C. This alternate reduction and pulverizing must be carried on until a sample of suitable size is obtained. This may be expressed very clearly thus: A equals 1,000 tons of rocks and lumpy ore. B equals 50 tons of rough stones, 1/20th of A. C equals 2.5 tons of small stones, 1/20th of B. D equals 0.125 tons of coarse powder, 1/20th of C. If the material to be sampled is already a dry powder, 5% of it should be heaped in a cone, each lot being added on the apex of the cone already formed, so that it may distribute itself by falling evenly in all directions. When the cone is completed, convert it into a low frustrum of a cone by drawing stuff uniformly and in a direct line from the center to the circumference. Draw 2 diameters at right angles to each other, and reserving any 2 alternate quarters, reject the others. Mix and form another cone, and proceed until a sample is got of the bulk required. Note: Figure 1 illustrates side views of a cone, a partly reduced cone with some of the material moved from the center out toward the sides, and the side view of a frustrum, effectively a disc with a sloping outer edge. There is also a plan of the frustrum divided into 4, with opposite sectors shaded, to be discarded. End note. This is the usual plan, and all samples should be tested in this way when the stuff is fine enough to fall evenly down the sides of a cone. Samples as they reach the assay office are seldom in a fit state for the work of the assayer. They are generally too coarse, and ought always to be more than he wants for any particular determination. The portion he requires should never be taken at haphazard. The sample must be reduced systematically to the quantity required. 1. If the sample is a liquid, it is sufficient to shake the bottle and take out a measured or weighed quantity for the assay. 2. If a liquid with a solid in suspension, measure the whole of it, filter, make up the filtrate with the wash water or water to the original bulk, assay it, dry and weigh the residue, and make a separate assay of it. 3. If of a creamy consistency, free from heavy particles, mix well, spread out evenly on a glazed tile, take up equal portions at equal distances, mix and assay. 4. If a mud of coarse and fine particles, or of particles of unequal density, weigh and transfer to a porcelain dish, or weigh in the dish. dry at 100 degrees centigrade. Weigh. Treat the residue as a solid capable of being powdered. 5. If a solid capable of being powdered or already powdered, heap up into a cone, flatten with a spatula, divide along 2 diameters at right angles, and carefully reject the whole of 2 alternate quarters, brushing away any fine powder. Mix the other quarters and repeat if necessary. For small quantities a fine state of division is essential. 6. If a solid with metallic particles, powder and pass through a sieve, the metallic particles will not pass through. Weigh both portions and assay separately. Sifting should be followed by a very thorough mixing. 7. If a metal or alloy in bar or ingot, clean the upper surface of the bar and bore through the bar. Use the borings. If the ingot or bar is small, cut it through and file the section. Filings must be freed from fragments of the file by means of a magnet, and from oil, if any be present, by washing with a suitable solvent. Note: ether or carbon bisulfide. End note. Where practical, metals and alloys are best sampled by melting and granulating. The student must carefully avoid any chance of mixing dirt or particles of other samples with the particular sample which he is preparing. 1 ore should be done at a time, and when finished it should be labelled and wrapped up, or bottled, before starting on a fresh sample. When an ore requires to be very finely ground in an agate mortar, it is often advisable to mix with a little pure alcohol, and rub until free from grit. Dry at 100 degrees centigrade and mix before weighing. When an assay is required of a quantity of ore made up of parcels of different weights and quality, each parcel should be separately sampled, and parts of each sample, bearing to each other the same proportion by weight as the original parcels, should be taken and mixed. For example, a lot of ore is made up of 1 parcel of A, 570 tons, one of B, 180 tons, and another of C, 50 tons. A sample representing the whole may be got by mixing 57 parts of a sample of A with 18 parts of a sample of B and 5 parts of a sample of C. A bruising plate, like that in Figure 2, is convenient for general office work. Note: Figure 2 shows a rectangular wooden table with a thick solid block of wood on the top of the table. On the top of the block of wood is a slab of metal fashioned as a shallow tray, open at one end, and tilting on a hinge attached to the wooden block, so ore can tip out of the open end. There is a flat-faced metal hammer resting on the table also. End note. The slab is of cast iron, about 1 inch thick. It is firmly supported on a solid block of wood and pivoted for convenience in emptying. The bruising hammer is steel-faced, about 4 inches square and 1½ inches thick. The block is firmly fixed to a small table or trestle, so that the slab is about 2 feet 6 inches from the ground. The slab is cleaned and the sample collected with the help of a stiff-haired brush.